Aloha, champions, and welcome back. It is Thursday, and you have yourselves another lovely science video to watch. We're still talking about energy and how energy changes our lives through fast-moving objects, through moving objects, and through energy transferring from one thing to another. Now, I know Mr. Chambers might have jumped the gun earlier with this weekend STEM project where you had to create the longest chain reaction that you could. And in each time that a domino collided with another domino, it was transferring energy. So the energy from one moving object to the other, it kept moving, and you might have heard sounds. You might have seen things fall over. The transfer of energy was there. Well, today, in Chapter 4, we're talking about how energy transfers from one object to another. So you've already put this into practice with your Rube Goldberg machines or your chain reactions. But now we're going to read about it. And as usual, during these readings, you're going to take some notes. Take some notes of what you learned in this. Then you're going to have 5 to 10 questions in Google Classroom to answer. Some of those will come directly from what I read. Some of those will be things that you have to apply your knowledge for. You have to read through the directions a little bit more and try to figure it out. Ask questions. Try to think deeper and deeper into this. Think like a scholar, and you'll be successful. So, without further ado, here is Chapter 4 of our first science unit, Energy Transfer. As usual, we have a big question, and this big question might come with a lot of smaller questions to make us understand this even more. But our big question for this is, what evidence shows that energy transfers from place to place? How do we as scientists know that energy is transferring from one place to another? Okay? And with that, it does come with a vocabulary term. This vocabulary term is energy transfer, which is a noun that says the movement of energy from one object to another or from one place to another. So moving objects transferring their energy, or if one object gives energy to another object, okay? So, that's our vocabulary term. We also have a new box, this box that says word to know. And this is words that you'll see throughout science, throughout reading. These are words that we want to apply to our everyday lives as scholars in thinking deeper about subjects. The word is evidence. And evidence is anything that helps prove or disprove an idea. Your own observations, sensory details, or information and facts presented by others can be used as evidence. You might hear this if you've ever watched a show where people go to court and a lawyer might ask, "Where is your evidence?" Or a police officer might say, "Here's the evidence." Okay? Scientists look for evidence. Scholars look for evidence. You're looking for evidence right now, right? Yeah. Scientists and engineers use evidence to support explanations about how and why things happen and to improve their solutions to problems. They're looking, they're observing, whether through their 5 senses or through what other people tell them, through what they can measure. Evidence, okay? And so scientists, they're asking the questions. Why does this happen? Engineers are asking the questions, how can we make this easier? How can we simplify things? So they're looking for evidence, looking for proof that they can do this, or that this is what the rules of the world, those high-level laws of gravity and everything else, how they apply to us. They're looking for proof and evidence, okay? So We have a vocabulary term of energy transfer and a word to know, evidence. Okay? But into the chapter we go. Chapter 4, energy transfer. Your friend is standing still on a skateboard. She asks you to give her a gentle push. Your friend starts out at rest. But when you push her on her back, she moves down the sidewalk, rolling away from you. Energy causes this change. When you push your friend, your motion energy, your kinetic energy, causes her to change from being at rest, standing still, to moving on the skateboard. When you push your friend, you can cause an energy transfer from you to your friend. Energy transfers between objects in contact, things that are touching each other, can give their energy back and forth. For example, if you kick a ball so that it hits a second ball, what happens? Well, when you kick the first ball, your energy from your body to the first ball, the position of the ball changes as it moves. When the first ball hits the second ball, it transfers its motion energy, kinetic energy, to the second ball. Now, the position of the second ball changes too. These changes in motion are evidence that energy has transferred from one object to the other. Energy can transfer in different ways. All forms of energy, including light, heat, electricity, and sound, are ways that energy transfers or moves. Energy can transfer from one object to another. Energy can also transfer from one place to another. You have seen examples of energy transfer between objects that touch each other. But are you in contact with the sun when we see its light? So if we look out the window, we see the sun. Am I touching the sun? No. But it's affecting me because I see its light energy from millions of miles away. Light can transfer energy over long distances through space. This energy transfer happens without the motion or contact of objects. I'm receiving energy from the sun, and I'm not touching it. I'm receiving energy from my light right here, and you see it sometimes. I have that glow, that circle glow. It's giving me energy, and you see that energy when I get that glare. This is light energy. It's transferring from one to another without touching me, without me touching it. Okay? Sometimes light can transfer energy. Light transfers energy from a light source, such as a light bulb, to your eyes. The energy of light causes changes in your eyes. These changes allow you to see things around you. The sun is another light source. Light from the sun transfers across 150 million kilometers of space to reach Earth. That's 93 million miles that the sun's light travels to reach us here on Earth. 93 million miles. It's a really long ways away. You can see the sunlight reflecting off your skin. Too much of the sunlight can cause an unpleasant change, a sunburn like this poor girl has here with her red shoulders. The sunburn is a change, evidence that energy was involved. Anytime something changes, there was energy. Sound can transfer energy. Sound energy comes from objects that are not touching you, but it causes changes you can hear and sometimes feel. Sometimes when a horn honks nearby or a firework goes off, kaboom! The sound energy pushes the air and you feel a push from that sound. Such changes are evidence that an energy transfer happened. So sound is a type of energy and it's transferring. Maybe from Mr. Chambers talking to his camera, talking to you, listening to it via YouTube. Sound is transferring. That is energy being transferred in the world. Heat can also transfer energy. Energy also transfers from place to place, such as heat. If you pour hot tea into a cool cup, soon the cup will get hot. So every morning at 8:30 when Mr. Chambers' coffee machine goes off and I pour that hot coffee into my cup that's been sitting in the air conditioning, the cup will eventually warm up. If I let a spoon rest in the tea, or coffee in Mr. Chambers' case, soon the spoon will get hot. This is because heat energy transfers from the tea to the cup to the spoon. The heat energy causes a change. It changes the temperature of the cup and the spoon. The cup and spoon becoming hot is evidence, proof, that energy has transferred or moved because the heat in one material, the tea, moved and produced changes in other objects, the cup and the spoon. Electricity transfers electrical energy, a different type of energy, but it still transfers. You're using an electronic device to watch this. I'm using an electronic device to make this. So electricity is transferring energy. A light bulb without electricity is just a thing made of glass and metal. But when you add electrical energy to the bulb, what changes? Well, it lights up and becomes a source of light, changing a room from dark to brightly lit. The glowing light is evidence that energy has moved from one place to another. The transfer of electrical energy causes the change from an unlit bulb to a lit bulb. Energy is transferred from place to place by electricity. Like all forms of energy, electrical energy moves from place to place and causes changes. You've probably seen power lines strung between poles along the road. These wires transfer electrical energy from power plants to homes, schools, and businesses. The electrical energy transferred through these wires causes changes when it is used to heat up your toaster or to light your room. People transfer energy to improve society. Well, now we're getting to the heart of science and what engineers and scientists do best. Try to make life easier for us by asking questions, by looking for evidence, and then applying what we know to fix things, to make society better, to improve it. And I'm sure it has improved life for you, because imagine a world without electricity. So people transfer energy to improve society. Engineers often solve problems by making energy readily available and useful. Scientists and engineers work to find new and better ways to use different forms of energy and transfer them from place to place. Hydroelectric power plants use a series of energy transfers so that the motion energy of water can be converted to electrical energy. So here we've got this reservoir, all this water that's blocked by this dam. This reservoir, the movement of water, a kind of motion energy, is one of many forms of energy in this dam. So the water has to keep flowing. It has to keep flowing. So when they open the intake, the water goes down, and when the water is needed for electricity, it is allowed to flow through the intake area. Once it is in the intake, the water travels in the underground pipes until it reaches the turbine. This flowing water has energy of motion. Okay, so it comes down the hill, hits this turbine. A turbine is a machine that looks like a fan, with blades that can turn around and around. When the moving water flows into the turbine, it pushes the blades. The flowing water transfers its motion energy and causes a change. The blade moves, spinning faster and faster. Okay, so as it's spinning the turbines here, it's turning this generator. This generator, motion energy of the turbine blades is transferred to the generator. A generator converts motion energy to electrical energy. Energy again moves from object to object. So the water pushes the turbine spins, and the generator cranks and creates electricity. These long-distance power lines, electrical energy is transferred from the hydroelectric power plants to homes and buildings through a series of wires known as power lines. These power lines allow electricity to travel far distances. Energy moves from place to place. Hydroelectric power uses flowing water to move large, spinning turbines. The motion energy of the turbines causes a change that produces electrical energy. And when the energy of electricity moves through wires over long distance from place to place. So whether it is contact to contact, something touching another and transferring its energy, or energy traveling along lines, energy is moving from place to place. Okay? Here in Arizona, well, technically Nevada, but Arizona-Nevada border, we have Hoover Dam, which was built in the Colorado River at the border where Nevada and Arizona meet. You can see this in the top photo, how the dam holds water back in a great reservoir. When water is allowed to flow through the dam into the lower river, the moving water transfers its energy to equipment inside the dam. This middle picture of a different dam shows how water moves through a hydroelectric plant with a great deal of energy. So all this flowing water, all of that's moving through turbines, and that's a lot of energy. Okay? Just think, if you're washing your hands, you turn that sink all the way up, and it's soon splashing you in the face. Well, here we've got millions times more water rushing through here, creating a lot of energy. Okay? The engineers are building the turbines that go inside a hydroelectric dam. So these are the big turbines. And can I see a person? Here's a person. So the turbine's like 2 or 3 times the size of a person. Energy from the moving water transfers to turbines like these. Then the energy transfers in the form of electricity through power lines to buildings where people work and live. And with that, that ends chapter 4 for us, and how energy transfers from one thing to another. We've put this into practice with our Rube Goldberg machines this previous weekend, so you know what energy looks like as it moves from one thing to another. Now apply that knowledge and answer the 5 to 10 questions in Google Forms to show that you've learned something through this video. And with that, I hope that you stay awesome. I will talk to you in our next video, and I'll see you real soon.